Hey everybody, today I'm going to do a simple differential equation. This method is called variation of variables, and the reason why I'm doing this is because when you get to the classroom and sometimes the teachers, they go explaining a bunch of things and a bunch of theory when you need a simple method to solve differential equations. And sometimes you get lost because the teacher starts going through very intensive theory that is good for mathematicians when you need to solve a simple differential equation for engineers. And that's why, because I have trial in the class and I learn more from the students than from teachers. Then what I'm doing right now is trying to share with you whatever I learned, and also because it was given to me from all knowledge that was given to me from other students, I want to transfer, I want to pass you some of that knowledge that I got from another students instead of from teachers. It's not that I'm complaining about teachers, it's just because a lot of times teachers, they go through a lot of material which is not needed for solving simple differential equations. So I'm doing problem number 5 in this book. Okay, this book is a first course in differential equations, and this is the book. I am doing number 5 on chapter 2.2, and the problem says the following: x dy over dx equal for y. So this is the differential equation: x times dy dx equal 4y. Okay, so this is the derivative, right? So this is the derivative, and I'm going to solve the differential equations by separation of variables. What I'm going to do, I want to separate the y and the x, the x's, the y and the x's, and I want to separate the derivative along with each variable. That's why it's called separation of variable, because I want to have the y with the y's, and I want to have the x with the x. Okay, so I want to go ahead and multiply across the dx, right? And I want to leave the dy and the x in this side. Okay, so I'm going to have x dy equal 4y dx, right? So now I want to go ahead. Now I have this, right? But I haven't separated anything yet, right? What I'm going to do right now is I want to divide both sides by y. Okay, so dividing both sides by y, I get that y, and then I divide by y right here. Okay, so this cancels, and I get x dy over y. Actually, you can put the little parenthesis right here, x, right, times dy and y, right, equal 4 dx on the other side, right? Now what I'm going to do is I want to divide both sides by x. When I divide both sides by x, I get dy over y equal 4 over x dx. Now I have separated, right? Now the next step is integration. So I gotta integrate both sides of this differential equation, because now it is separated. I have a dy and the y variable, and I have a dx with the x variable, which that's what I want, right? So now when I go ahead and integrate on both sides, when I integrate on both sides, I get, in this piece right here, I get ln of absolute value of y equal for ln absolute value of x plus c, right? Notice that I could have a plus c on this side too, but it's not necessary because they are both constants on both sides. What I'm going to do right now is I'm going to take the e on both sides of this equation to get rid of the ln, because I want to solve for y. That is my goal. I want to have this equation at the end and the y equals to something, right? So I'm going to go ahead and take the e. Okay? When I take the e on this side, this disappears, right? So I get y. Okay? And if I take the e on this side, notice that in this side I could send this to the front, and I can rewrite it as the e times the ln of absolute value of x to the fourth, right, plus c. Okay, so notice that this piece right here is being this e right here is the exponential. Okay, so if that e right here, this piece right here, e is this piece right here is the exponential of e, right? It's like the e to the x. In this case, I have the whole piece. What I'm gonna do is this one right here disappears, right? When I take the e of that side, that disappears, and I get what? I get just x to the fourth, right? And then that and that is the same as one piece. So technically, this c comes to the front, and the answer for that is y equal c x to the fourth. Okay, see how that was? Not too difficult, right? Not very difficult, but teachers, again, they make sometimes difficult because they explain a bunch of theory in the stuff when the method is not too bad. It's not really bad. So, okay, so that is that one. Okay, so the answer for that is y equals c x to the fourth. Okay, so c is a constant. Okay. So c can be anything. So now let me do another one real quick. Okay, I'm doing number in the same book. Okay, I'm doing number 1 right now, and then number 1 is dy dx equals sine of 5x. Yep. So again, I'm going to separate the variables, and I get dy is equal to sine of 5x dx. Okay. This is even easier because I didn't have to deal with the stuff on the left side. So, okay, so integrate on both sides, and I get, in this case right here, just get y, okay? But in this side right here, when I integrate that becomes the integral of sine is negative cosine, but I have the constants. I have this piece right here, which this argument of 5x is like it's like a dividing. It's like a dividing by 5x. So if I do that, I'm going to have cosine, right? Cosine of 5x, right? Divided by 5, right? Because I'm divided by the constant, the argument in front of the x, right? So, and plus c, okay? So this is nothing but 1/5, negative 1/5 cosine of 5x plus c. That's it. Alright, I hope this helps. And again, I am doing this because I want to share some of the knowledge that I learned, and not too much from teachers, but talking to different students who have been, experimenting that a lot of times we learn more by talking each other and discussing things each other instead of sitting at the class confused, trying to follow a theory that the teacher who has a PhD in mathematics cannot explain it so well, and plus you don't need that sometimes to do differential equations for engineering. Alright, thank you. Alright, I hope this helps.